Hello everyone, welcome to In 5 Minutes. In this video clip, we will discuss next problem on nodal analysis. The question is determine the current through 3 ohm resistance. There is one 3 ohm resistance in the circuit. We have to find out how much is the current through this 3 ohm resistance. The direction of the current is not mentioned and hence I can assume any direction I want, either towards right or towards left. So we will see which direction we want to go for at the end. But before that, because we are going to apply nodal analysis, the very first step will be to identify the nodes and then apply KCL equations on each and every node. Now this is something is already done in this particular circuit for us. You can see that in this circuit there are total 4 nodes. This is node number 1, this is node number 2, this is node number 3, and this is the bottom node, which is also mentioned to be reference node or the ground node. So this becomes my ground node. The voltage at this bottom node, which is the 4th node, will be 0. So I'm now left out with the 3 nodes at which I have to apply KCL equations. So very much similar to few of the previous questions that we have done. Just that once we get the values of V1, V2 and V3, we have to find out the current through 3 ohm resistance. Now, because we don't have to find V1, V2, V3 and only the current through 3 ohm resistance, it is always better to quickly figure out what all information we are going to need to find this current through 3 ohm resistance. So as you can see in this case, the current through 3 ohm resistance can be found the moment I know the values of V1 and V2. The value of V3 is not required. But because there are 3 nodes, when we write KCL at node 2, V3 will also come into picture and we will have to solve 3 simultaneous equations and find V1, V2, V3, all the 3, and then only go for finding out the current through 3 ohm resistance. So that is going to be the approach. We will write 3 equations and solve them simultaneously. So let's start with the very first node. I'm saying KCL at node 1. So KCL at node 1, this is my node 1. Let me define 3 outgoing currents. Now see, in this case, we generally always define outgoing currents, but there's a current source in this branch. Whenever there's a current source in the branch, then it is always better to stick to the direction of the current source, which is also outgoing with respect to node V1. So there is no problem here. So this is outgoing current and we define 2 more outgoing currents. So my KCL will be this current is equal to 4 amperes. This current is V1 by 2 because there is no other voltage source, node voltage upon the resistance, plus now current through 3 ohm resistance, because it is flowing towards right, will be V1 minus V2 upon 3, and this will be equal to 0. So let's quickly solve this equation and see what is the final equation in the form of V1 and V2. So you can see the LCM will be 6. It will be 4 into 2 into 3 plus 3V1 plus 2V1 minus V2 equal to 0. And hence finally it becomes, I'll keep V1 on one side, so that gives me 3 plus 2, 5V1. You can see this is minus 2V2 and this will be 24, which I'll send on the other side, becomes minus 24. So this gives me one complete equation in the form of V1 and V2. I'll call it equation number 1. Let us now proceed to write the KCL at node 2. So KCL at node 2 will be with respect to voltage V2. But before we do that, let's define the currents. Like always, we define 3 outgoing currents. Let us start from current through 3 ohm resistance, which is now flowing towards left. Because it is flowing towards left, because it is starting from node 2 and ending on node V1, the current expression will be V2 minus V1 upon 3. So that's my first current, V2 minus V1 upon 3. Plus, now the second current will be through this 2 ohm resistance. If this voltage source was not there, we would have written it as V2 by 2. But because there's a voltage source here, we have to be now little careful. Because the current is flowing in the downward direction, let us first mark the voltage polarities across 2 ohm resistance. Current is flowing in downward direction, so the voltage fall will be shown with this polarity, plus on the top and minus on the bottom. So now let us write down the total potential difference across 2 ohm resistance. The potential difference will be the voltage on the positive polarity side, which is V2, and voltage on the negative polarity side. Now if you observe, the voltage on the negative polarity side is the negative terminal of the battery, and hence the voltage on the negative polarity side will be minus 20. These are the two voltages, V2 on positive side, minus 20 on negative side. Why we write minus 20? Because the negative polarity is connected to the negative terminal of the battery. and because it is potential difference, we have to take difference between V2 and minus 20. So that becomes my complete potential difference across 2 ohm resistance. Divided by 2 will give me the current through this branch. If the battery polarities of 20 volts were like this, then we would have written V2 minus 20, that's it, divided by 2. But because they are inverted, we have written V2 minus of minus 20. I hope this is clear to everyone. The third current will be through 5 ohm resistance towards right. It will be V2 minus V3 upon 5.